Okay, now let's look at the magnetic field from an infinite current filament. So this is what you have learned from the biot law, and it is used to calculate the magnetic field, okay, when you have been given a current filament. Okay, so now we will focus on infinite current filament. Okay, so what is infinite? Okay, infinite is current filament that you don't know the length. Okay, you don't know what is the length of the current filament. And for the finite current filament, you know the length. So we normally use this one for finite line to calculate its magnetic field. Okay, let's look at what happens when the current filament is a semi-infinite line. So semi-infinite line, it means that you know the starting point or you know the ending point, one of it, and the other end it is extend to infinity. For example, like this case, the current filament start at 0 and then it extend to infinity here. So we call this kind of line as semi-infinite line. So for semi-infinite line, okay, we can simplify this equation, okay, because the angle can be determined. Okay, so if you look at this case, okay, so this is point A and this is point B and this is the observation point, and alpha 1 will be equals to 90 degrees, and when this point extend to infinity, okay, the alpha 2 will be approximate to 0. So when we replace this angle into the equation, finally we will be able to simplify the equations to become this one. So this equation is applied when it is semi-infinite line. And for infinite line means you don't know where is the starting point, you don't know where is the ending point, because they are located at infinity, like this case. Okay, so for this case, okay, the alpha 1 will be approximate to 180 degrees and your alpha 2 will be approximate to 0. So in this case, when you insert the angle into the equation, your final equation will become this one. Okay, much more easier. So let's look at how to use these equations in different example. So we will proceed to example. Here you have 3 examples, so we will do it one by one. Okay, the first example, let's read the questions. So you have an infinite current line of 3 ampere and it's laying along the x-axis. Find the intensity of magnetic field, which is the H at this point. Okay, so we just jot down the important informations, amperes, okay, and also the location that we want to know the magnetic field, and it is along the x-axis and it is infinite line. Okay, so by refer to the equation that I explained just now for infinite line, we should use this one. Okay, so this is the equations. Still, we have to draw the current filament because we need to determine the R here. Okay, so this is the current filament, okay, from negative infinity to infinity. It is infinite line. Current flow in the positive x directions along the x-axis, and this is your observation point, point P. To know the magnitude of R, first of all, we need to define, okay, where is the vector R. Okay, so the vector R. So the vector R can be obtained by linking the observation point with a point that is located, okay, along the current filament. And this line will form a 90 degrees, okay, here. So if according to this coordinate, okay, we are very sure that, okay, the T point here has coordinate y and z equals to 0, so I will insert this 0, 0 here. And for the coordinate of x, you just take the coordinate x of observation point, okay, make it to be the same. If this is 1, this one also must be the 1. Okay, so this one is the location of point T that form 90 degrees. And in order to find the vector R, you just do it as usual. Okay, so this is the way we find the vector R, okay, the magnitude R, and also the unit vector R. Okay, and lastly, we insert it into the equations. This is the current, the 2 pi R, and then this is the direction of the current, which is dl, and this is the unit vector R here that you obtain from here. Okay, so you cross product xy, you get z, and x, z, you get negative y. Okay, so calculate as usual, you'll be able to get the magnetic field intensity, this one. Okay, next, let's look at example 2. This is the example 2. You have an infinitely long conducting filament, okay, current filament, and it is placed along the x-axis. The current is 10 milliampere. Okay, it is also in the x directions, so you have to find the h at this point. So this exercise 2 is very similar to exercise 1. Okay, just we change the value. Okay, so everything important information I will jot down. Okay, so I will draw this current filament, and now I have to determine where is the point T and what is the coordinate of point T. Okay, point T is located along the current filament, and this current filament, it has coordinate y and z equivalent to 0, 0. So I'm very sure that this is 0, this is 0. And for the x coordinate, I will take the coordinate, same coordinate as the observation point. This is 2. And I find is vector r, which is the observation point, minus the source point. Okay, the source, the current point, which is the point T. And I get 5 for magnitude, and I get this one for my unit vector r. So I replace it to the equation here. So this is my dl, and this is my unit vector r, and I get this answer. Okay, so now let's move on to the example 3. Okay, so for example 3, it is a semi-infinite current filament, and it begins at this point. Okay, semi-infinite line is a line that you know the starting point or the ending point. You know one of the location of the point, and it extends to negative infinity. Okay, in negative y direction. Okay, and it carries current 4 ampere. And find the h at this point, negative 2, 3, and 1. Okay, so let's look at this example 3. So I jot down all the information. Negative 2. Okay, sorry, this one should be 8. Okay, should be 8. And 1. Okay, so if according to the formula, okay, for semi-infinite line, we should use this equation. Okay, we should use this equation. But this equation is defined when your alpha 1 is equivalent to 90 degrees and your alpha 2 is equivalent to 0, right? But let's look at this case. We have to check whether our alpha 1 is 90 degrees or not, okay? And alpha 2 is 0 or not, okay? This is the original equation, okay, for finite line. So when I draw this semi-infinite filament, it starts from the 0, 6, 0 and extend to negative infinity, current flow in the negative y directions. So first of all, I have to link the observation point, okay, with the ends of the current filaments. Okay, so this one will be your point A. Okay, it has smaller value, and this one is your point B. So your alpha 1 is here and alpha 2 is here. So in this situation, your alpha 1 is not 90 degrees anymore, right? When the point A is extend to negative infinity, okay, your alpha 1 will be approximate to 180, and it is not 90 degrees. And for your alpha 2, it is also not 0, okay, it is also not 0. So which means that you cannot use this equation. You have to use back this equation. Okay, so we continue the steps as usual. Find the point T. Okay, point T is situated along the axis, okay, of the current filament. Okay, so you are very sure that the x is 0 and the z is also 0. And for the coordinate y, you follow the coordinate of y of the observation point, which is 8. Okay, so this one will be your T point. So for using this point T, you can find the vector r, the magnitude of vector r, and also the unit vector r. This one is a usual step. Okay, you must be familiar with all these steps. Okay, next is we have to draw a triangle because we already know that this alpha 2 is not 0, so we have to find its angle. So I draw this triangle. Okay, so this is a triangle that I draw. Okay, alpha 2 is here. So this is 6, okay, and this is 8. Okay, so the length here will be 2, and this one is the magnitude of vector r, square root 5. Okay, so I use tangent, arctangent, and I find that my alpha 2 will be equivalent to 131.81. Okay, next is to find the unit vector phi. Okay, so I cross product the negative y, which is the direction of the current flow, okay, with the unit vector r that I calculate here, and I will get this one. Okay, so everything you just follow the steps of the finite current filament, even though it is semi-infinite line. Okay, so by replacing, okay, all the relevant information into the equations, you can get this answer for your magnetic field H.